Alright, so today we're going to be doing a video. What's this video going to be about? It's going to be about a spec. Oh, that's not okay. Okay, so welcome to Sharktech. Here goes our video. It's going to be about the spec, how to use it, how to calibrate it, and a bunch of random other things that I'm going to put in the video for no reason. So, alright, so here we have a spec 20. So it's called a spec 20. You see that right there? Okay, now I completely erased it. And I'll get the highlighter. Here it is. Okay, so, oh, oops. Okay, anyway, so the parts of the spec. Here you have the readout. Okay, so that's going to tell you right here the wavelength that you're on. Right here, it's going to tell you the absorbance. All right, there are some buttons over here. On ours, it's going to be like this. That are going to be the buttons that'll select the mode. Okay, so you have some parts. First, you have the transmittance switch. On ours, it's going to say 0% T. This one's going to say 100% T. Here you have the sample area where you're going to pop it in. You're going to have a cuvette. You're going to fill it with water. You're going to have some particles in there. You're going to pop that in. Just pop it in. Pop it in. You're going to pop it in there on the spec, and that's how you're going to use that. All right, so let's get this back to a pen. All right, so what else do you have? You have the wavelength control. So what's that do? So when you have a sample, say you're going to have a lambda max. So that's going to be, you're going to plot the wavelength versus the absorbance. And basically you're going to find where you're going to get the peak absorbance for that specific material, and that wavelength is going to be your lambda max. And that's what you always want to run your sample on. So, alright, so now we'll move on. Alright, so now that we know the parts of the spec, now we're going to talk about how we're going to start using the spec. So what you're going to need to do is first, before you use the spec, you're going to have to blank it. So what that means is you're going to have to move this knob, if you remember from the last part. This is your 0% transmittance knob. So what you want to do is first you want to take this knob, wavelength, and you want to set it to whatever wavelength you need. So say you need 440 nanometers. Alright, so what are you going to do with that? Well, now you're going to turn the one on the left all the way to 0. Over here it's going to say something, let's say it says, oh, that's not easy to see, 67, whatever, and you need to get it to 440. Shoot. Alright, so the first thing you have to do is you have to set it to use the sample. So we're going to have to set, this is your wavelength knob, you're going to set that to whatever wavelength you need it to be. So for our purposes, let's say it's 440 nanometers. Okay, so if say it says 67 over here, you need to move the wavelength over to 440. So you're going to turn this knob this way till it says 440 over here. Alright, so what are you going to do with that? Then you're going to change the knob, the button, you're going to change it over to transmittance. And you're going to move this knob, this is your 0% transmittance knob, you're going to turn that this way until it reads 0% transmittance. So then what are you going to do? Well, you're going to have a blank. Your blank is going to be a cuvette filled with distilled water. So it's going to be a blank sample, nothing is going to be in it, you're just going to take that sample. What are you going to do with that? Well, you're going to pop it in. Pop it right in there, pivot, pop it in there, pop it in the spec, you're going to pop it in there. So once it's popped in there, what are you going to do? Well, you're going to turn the second knob, this knob, from 100% to 100%, place it inside, and switch this, pop this over to wavelength, and you're ready to read.
Some say love, it is a river that drowns the tender.
Alright guys, so chemistry, biotech. So today we're talking about Beer's Law. And what Beer's Law is A equals E B C. Alright guys, so E is the molar absorptivity. B is a path length, and they're both constants, so you can cancel them out. So A is directly related to C. That's basically what Beer's law says. As concentration increases, absorbance increases. So let's go to this bag. So when you have your little cuvette here, fill it up with whatever you're measuring. Here's your spec, and light's going through, and some bounces off, and some goes to the sensor over here. As it goes through, some bounces off and goes back, and the other gets here, and that records our absorbance. As the concentration increases, so does the absorbance.
Some say love, it is a river that drowns the tender reed.
Guys, so I'm going to show you how to make a standard curve. So here we got our values, concentration and absorbance. And we have to plot this on a graph at Excel. The y-axis is going to be absorbance, x-axis is going to be concentration. So you plot all your points, and then Excel will give you a standard curve and an equation. Y equals the slope of that curve plus whatever number it gives you. So let's say 14. Okay guys, so now I'm going to show you how to find concentration or absorbance given the standard curve. So here we have our curve. Y equals the slope times absorbance plus whatever. Now, if you have the absorbance, you can use it, plot it on the curve to find where the concentration is on the x-axis. Or you can plug it in to the equation. Oops. And then the x value you get will be your concentration. Alright guys, that's it. These are the lines. This should be you, not this. This is the gazelle. Bam. Alright, done recording that video. Oh, hey Nelson, nice time. Does it come in minutes?
Good one. You know, I just finished giving a quiz. Every day's a quiz in my class. I got a quiz Monday, Tuesday, Wednesday. Every day's a quiz. It doesn't even have to be on anything you've taught them yet. You should give a quiz every day too.
Oh, that's interesting.